In this video we're going to look at solving linear equations. So the golden rule when it comes to linear equations is whatever is done to one side must be done to the other side. Okay? So if you think of adding something, the opposite operation is subtracting. Okay? If you think about multiplying, the opposite is dividing, and so on. Okay? So if you keep that in mind, if you want to get rid of something that's been added, you take away that same value. If you want to get rid of something that's been multiplied, you divide by that same value, okay? And vice versa. Okay, so in this first example here, we have 3x plus 2 equals 5. Okay, so we want to get all of our x terms on the left-hand side of the equal sign and all our numbers on the right-hand side of the equal sign. Okay, so the main thing that we need to get rid of here is this plus 2. That's our first problem. Okay, so remind yourselves that the opposite to plus is minus, so to get rid of this plus 2, we're going to take 2 away. Okay, and whatever we do to one side, we must do to the other to ensure that the equation stays balanced. Okay, so we have 3x now, 2 minus 2 is 0, okay, and then that's equal to 5 minus 2, which is 3. Okay, and then finally we want to get rid of this 3 because we want to find what x is, not 3x. Okay, so if we have 3 x's and we want to find what x is, that's 3 multiplied by x. So if we divide both sides by 3, 3 divided by 3 is 1x, or just x, and 3 divided by 3 is 1. So in this case, x is equal to 1. In question 2 here, we have x divided by 5 equals 10. Okay, so if we think about this logically, a number, x is just a number we don't know. A number divided by 5 is equal to 10. So instinctively, we all know that that actually is 50. But the way that we do that using algebra is, remember we talked about the opposite to multiplying is dividing? Well, the opposite to dividing is multiplying. So if we want to get rid of this division by 5, we're going to multiply by 5. Okay, and whatever we do to one side, we must do to the other side. Okay, so 5 divided by 5 is x, we're left with x, and 10 multiplied by 5 is 50. So our answer is x equals 50. This last question is typically what we would get in an exam. Okay, so it's quite a long question. It involves brackets, so the first thing we need to do is get rid of those brackets. Okay, reminding ourselves that to get rid of a bracket, the term outside is multiplied by the terms inside. Okay, so 3 times x is 3x, 3 times minus 6 is minus 18. This plus 15 is just on its own, so we'll rewrite that down. 2 times 2x is 4x, and 2 times minus 2 is minus 4. Okay, and that plus 4 is tagging along at the end. Okay, we're going to do a little bit of simplifying here. We can add up some like terms, so as you can see, 18 and minus 18 and plus 15 can be added together, as well as the minus 4 and the plus 4. Okay, so we have 3x minus 18 plus 15 is minus 3, 4x, and then minus 4x plus 4, or sorry, minus 4 plus 4 is just 0, so those actually cancel out. Okay, back in the previous question we wanted all of our x terms on the left side and our constants on the right hand side. Now it doesn't actually matter. We can take our x terms to the right hand side, which would make this question a little easier. So once x is on its own, that's the main idea. Okay, so we want to get rid of this 3x from the x from this side. Okay, so in order to do that, we're going to take 3x away. So this is plus 3x, so to get rid of it, we're going to take 3x away. So we're doing it as you can see, and so those will cancel. 3x minus 3x is 0. We're left with that minus 3. And then 4x minus 3x is in fact just x. So our answer is x equals minus 3. Okay. Next up we're looking at manipulating formula or rearranging formula. So as you can see in this first example, it says express I in terms of R and V. So we're not going to be solving for any letter here. We're going to be rearranging we're not going to have a number at the end. We're going to rearrange this formula, so our answer is eventually going to look like I equals something, and generally it will have R and V in the answer. Okay, so when we do that, we're going to try and get I on its own. Okay, Now at the moment I is being multiplied by or because the two letters are written beside each other with no signs in between. Okay, so that means they're being multiplied. So to get rid of that or, we're actually going to divide both sides by or. Okay, or divided by or is actually just 1. So the or's have cancelled there and you're just left with I on that side. Okay, and then V over or on the left hand side. Okay, now I know we wanted I equals, so it's easy to just flip these over, so we can say I equals V over or. This next question is a little bit longer. Express or in terms of the other variables, so A equals pi or squared, so we want or on its own. Okay, our first step is going to be to get rid of that pi. Okay, so pi is being multiplied by the or squared at this point. So in order to get rid of it, we're going to divide by pi. So those pi's will cancel there, and we're left with A over pi equals or squared. Now, as we talked about in the previous section, plus is the opposite to minus, multiply is the opposite to divide. The opposite to squaring, so x squared, is actually the square root of x. Okay, so they're called inverse operations. So if you do that, if you get the square root of x squared, you're just going to be left with x. Okay, so here we're going to actually get the square root of or squared. And remember, whatever we do to one side, we must do to the other. Okay, so when you square a square root or square root a square, you're just left with or. Okay, so the square and the square root will disappear, and our answer there is A over pi.